Hello students, I got some questions especially about histograms from the first homework set. So let's talk about those, but of course I don't want to give away the answer, so I created some alternative problems here. And this is the original problem set. I gave you this data and then I asked for dot plot and then some frequency table and histogram. And this is parallel problem, alternative problem. Here is different set, and then different data, 207, 239, another 239, and so on. And then this is automatically generated stem and leaf display. And if you can't see any of those, maybe I should have done that. Even if the data set is not there, you should be able to retrieve those data from here. So 20 and then 7, and stem units is 10th digit. So 20 and then 10. So this is 200. 207. So you can retrieve the data set like this. 207 and then 239 and then 99. So another 9. 239 and then 241, 24, next number is 3, right? 3, 248, 249, and all these are from 24 something. And then how many numbers are there in 26 something? 2466689. So you can recreate all those numbers there. So let me just write down dot 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 over here. And that's a data set. And let me open up the original data set again. This is the original data set, and then this is stem and leaf display. And even with stem and leaf display, you can retrieve the data set, kind of like this manually. Now using this, you can produce a dot plot. How do you do that? Just get a ruler and then get a horizontal line. And then the horizontal line starts from something that includes 207, the smallest, and then something that includes 299, the largest. And here in my suggested answer key, I started from 200 to 300. And I could have started from, say, 205, but, well, 200 seemed appropriate because it's a simpler number, like this. And by the way, a lot of people may start from maybe about 230 or even 235, considering this one as an outlier. This does not really fit anything, so throw that one away and then take on this part. And that's a legitimate argument, but in my class, I'm including all the I'm including all the outliers. Usually I do it like that. Okay, all right. So far, no problem. Or shall I talk about it a little further about the dot plots? Let's see. Each dot represents a number. And for example, there are 239, so 239 over here, and another one goes on top. And then let's see, we have 266. So we have 3 dots associated to 266 right here. Anyway, that's a dot plot. Okay, even with dot plot, you can make appropriate guess about where the separation occurs. There's this bunch, and the second batch, and then third batch, and then fourth batch, kind of like that. So this is not a kind of bell curve kind of thing that we have concentration in the middle and then dispersing out. We have multimodal kind of situation. We have a bunch, another bunch, and then smaller bunches like these. And this problem specifically gave you the class interval 200 and 220 around here. That's one class. 220 to 240, that's the second class. 240 to 260, that's a third class, and so on. And let's talk about histograms. Ready? Okay, so this thing is called frequency table. Given class interval 200 to 220, 220 to 240, 240 to 260, 260 to 280, 280 to 300, okay. Okay, those are class intervals. And let's count how many numbers or how many data you can find in that interval. I'd like to get that data set back down here. Okay, all right. Okay, that's the data set. I just copied and pasted. And then among these, how many numbers fit into the first class interval, 200 to 220? I see only one, which I just highlighted in red. I see only one. So 1 is the frequency. Making sense here? Now, 220 to 240, greater than or equal to 220, but strictly less than 240. How many data out there? Here. I see two of them here, 239 and another 239. Are there any more? Any more between 220 and 240? I don't see any. So there are two of them. Let me highlight in blue. Next, between 240 to 260, how many numbers are there? I see this many. 241, 243, 248, 249. Okay? How many are there? There are 4. So let me write down frequency as 4, and again let me highlight appropriate color coding. So I use green for those. And now 260 to 280, how many are there? Count. How many are there? By the way, 280 does not belong here. Does not belong there. It's strictly less. 280 is the next class, okay? This is the way we do frequency intervals in math classes. In other classes, in other circumstances, we may do things differently, but in math class, always less than or equal, and then strictly less like that. If you want to remember, consider these as graded distribution. You just made precisely 90.0 and you ended up with B. Are you going to get mad? Oh yes, certainly. You deserve an A. 90 or higher should be A, not B. So strictly 90 is not B. Same goes to strictly 70. Precisely 70, you earn C. That's not a D, right? So precisely equal to that threshold belongs to higher class interval as far as math courses are concerned. And then this one, how many are there? How many between 260 and 280? 1, 2, 3, 4, 5, 6, 7. And I'm running out of colors. Okay, pink, magenta, okay, all right. And there are 7. Okay. Did I count correctly? Okay, and then greater than or equal to 280 and less than 300. The final, okay, I'll leave that as black. And there are 4 of them. Did I count everything correctly? That's called frequency table. Now, if you ask frequency table, that's enough. But sometimes you may have to get relative frequency. Sometimes. Well, okay, I admit it. I gave many exams, and I've never given relative frequency problem in exam level. Of course, there are relative frequency problems in homeworks, but in exam, I've never done that. But hey, well, why don't I start now? Or it's not really carved in stone, so let's talk about it. What is relative frequency? Percentages of all these. So how many total are there? So there are total, let's see, 8, 10, there are total 18 numbers. Let's see. Yeah, there are total 18 data. And out of 18, 1 out of 18 is the frequency. And 1 out of 18, what is 1 out of 18 in decimal? About 0.0125, okay, 0.0125, or if you like percentages, 1.25%. Oh, excuse me, mistyped it. Okay, 0.055 something. Okay, and then this is no longer equality, it's approximation now. So this kind of thing is relative frequency. Shall I do it again for the next one? 2 out of 18, approximately equal to, and run your calculator. 2 out of 18, what is it? 0.111 something. Next, 4 out of 18. Okay, and you get the picture. 7 out of 18. And then this one is 4 out of 18 again. So if you get all the relative frequencies and add them all up, you have to get total. Total should be 1. If you prefer percentages, total will be 100%. Here, if you add a frequency, then total will be the number of data, 18 in this case. So based upon frequency or relative frequency, you can produce a histogram. It's easier to produce with frequency and it takes less amount of time. So I usually use frequency, and in the first exam, I almost all the time write a problem that students have to produce frequency. Students have to produce this, what do you call the histogram with ruler and paper and pencil. And there, I don't really want extra time spent on relative frequency computation, so I usually require frequencies only. And the picture looks kind of like this. It's not a bar graph, it's a histogram. And what are the characteristics? To the horizontal, we have class intervals. Okay? Class interval, all these numbers, 200, 220, 240, 260, 280. Do you see these? Those are starting and then ending at 220, 240, and so on. So 200 to 220, 220 to 240, 240 to 260, 260 to 280, 280 to 300. We have each intervals horizontally. Vertically, we have frequencies. The first box goes up to 1, second box goes up to 2, third box goes up to 4, and then fourth rectangle goes up to 7, as you can see. Those are heights. Now, if you use technology, then you can produce something cool like this, but if you're using just plain paper and pencil, in that case, please use rulers or something straight to produce something that I can easily see so that I can easily give you credit. Or even if you use your hand, still try to produce as straight as possible. And this is exactly the same picture except scaled accordingly. Look at this vertical. Instead of going from 0 to 7, it's going from 0 to about 0.4, and those are relative frequencies. So we have relative frequencies, or decimals, or if you prefer percentages. And these are all scaling, so this picture here and that picture should be exactly the same. Just by looking at the picture, you cannot see whether it is given by frequency or relative frequency. You can see it only by looking at those scales. Now, how do you produce these histograms? By creating the frequency table like this, getting the class interval and counting. And this is extremely important, and as I said earlier, I usually write this kind of problem, well, let's see, I have taught elementary statistics over a dozen times in college level, and I've never missed it, as a matter of fact. Every single semester I wrote one, so this is not likely to be an exception either. So please make appropriate preparation for exams.